I'm Mike Eckert, and I'm in the group with Hayden and Jake. My job right now is to explain second class levers. As you can see here, this is a second class lever. This right here is the fulcrum or the pivot, the middle is the load, and at the other end is the effort. One example of a second class lever is a wheelbarrow. The fulcrum is the wheel, the load is whatever is inside the wheelbarrow in the middle, and the effort is you picking it up at the other end. Another second class lever is a bottle opener, and a nutcracker. How the bottle opener works is the fulcrum is right there. It's at the end. It's prying the load, which is the bottle cap, up with effort. The nutcracker, the effort is at this end, and the load is the nut, obviously. And fulcrum is where the nutcracker is bending.
Hi guys, my name's Hayden. I'm in the group with Micah and Jake, and I'm here to talk to you about third class levers. So basically, a third class lever is when the effort's in the middle, the load is on the front, and the fulcrum's in the back. And some examples of that are a fishing pole. So your left hand is both hands are on the rod, but your right hand is the fulcrum, and your left hand is the force, and the fish is the load. So basically, another example is your arm. Your elbow is the fulcrum, where the muscle is the effort, and whatever's in your hand is a load. So basically, everything, your whole body could possibly be a lever if you wanted it to be, but here's just the best example is your arm. So you have the load, right here is where the effort is, and your elbow is the fulcrum. So it just basically works like this. And that's third class levers. Another example is a baseball bat. The bottom of the bat is the fulcrum. The effort is your right hand because of your wrist, the pivot point of your wrist, and the resistance is the load. So an example of that would be hitting a baseball.
So I'm Jake Rufo, and I'll be explaining to you mechanical advantage. Mechanical advantage is basically the theory of you're putting in less effort to do the same amount of work. Just as if you put in, if usually it takes 50 newtons to pick up something, you're only using 10 newtons, so the mechanical advantage would be 5. So, just as in this diagram, the woman is putting down, the woman is trying to pick up 30 newtons, but she only has to put in 10 newtons. So basically, that means her mechanical advantage will be 3. Therefore, mechanical advantage is force output over force input. As force decreases, distance increases due to the mechanical advantage. Therefore, as well, 5 times mechanical advantage means you only have to put in 1/5 the effort for the same amount of work. When calculating the mechanical advantage of a lever, you take the distance, 1, which is the distance between the effort and the load, and divide that by distance 2, which is the difference between the load and the fulcrum, and that gives you the mechanical advantage. I will now tell you how to determine the mechanical advantage of a second class lever. Here's the fulcrum. Here's the lever. Effort is put right here. Whereas the load is put right here. And this is distance 1. This is distance 2. This is distance 1. And then you would put, this would be 10 meters. This would over 1, which equals 10. Okay. For a second class lever, we have the load here, effort here, and then here is the fulcrum, where this is distance 1, this is distance 2. So if we were to take, 5 in for this, 10 in for this, it would be 5 divided by 10, which is equal to